In question 16, we are trying to get r alone on one side of the equation because right now, v is alone. If I look at r, it's being multiplied by pi and h, and it's also being squared. So I am going to use my inverse operations to get r completely alone. So let's first divide both sides by pi and h because it's being multiplied by the r squared. Since pi divided by pi is 1 and h divided by h is 1, we're left with v divided by pi h is equal to r squared. Next, let's use the opposite of squaring, which is taking the square root of both sides. And we are left with actually this entire thing because it can't be made any simpler. So our correct answer is answer choice 1. I'm hoping that all of you got super excited when you saw question 17 because this is a completing the square question. If you look at the answer choices, it's almost written in vertex form except for the shift up or down has been moved to the right-hand side of the equation. So let's go ahead and complete the square. First, rewrite the equation so that we have a little bit of space to write the two values, one that completes the square and the other to cancel it out. So right now we are looking for two values that add to 6 that are the same number, and you can get them easily dividing 6 by 2, which is 3 and 3. So the missing piece to our puzzle is 3 times 3, which is adding 9. So this here is equivalent, and if we add 9, we subtract it and combine those together to get minus 16. Now I'm going to write the minus 16 on the other side of the equal sign because that's what my answer choices look like, which makes it easy to see that answer choice 4 is correct. Question 18 is actually quite easy, even though it seems really difficult. So if you read the clues, it says which statement is true about the solution to the system. Now, if we think back to solutions of systems, we know that it's a solution when it makes both of the equations true, or the point or points of intersection. So if we look at all of our answer choices, we can only pick answer choice 3 to be correct because it satisfies both equations. Answer choices 1, 2, and 4 only deal with answering one of the equations, and it has to be true to both. Question 19 is a pretty tricky question, so my recommendation for this problem is actually back solving. So taking the numbers that they gave us in our answer choices and substituting them in to see when the two functions are the same, because we're trying to look at the same growth over time. So we're given these two functions. They told us that Miriam starts with 16 bacteria. After we substitute in 16 for the n, which they set up here, what we're going to do now is graph this function. Then on the same graph, we are going to graph this function here, and every answer choice we're going to replace the question mark. So I'm going to first start with 32, then 16, 8, and 4 until I get these two graphs to become the same. Here you can see that I've graphed the two functions, and my base that ended up working out nicely was 4. So answer choice 4 is correct. I also showed the table of values to prove, yes, these two functions are the same. Immediately when I see question 20, I see the word sequence. So that indicates to me that I need to make a table and use my before, now, next rule. So here's our table with the initial value of 2, and we're looking for the f of n value when n is 2. Let's use our before, now, next to help us. So we know the next is equal to negative 2 times the now plus 3. So negative 2 times the now, which is 2 currently, right here, plus 3, which is negative 4 plus 3, giving us negative 1. Now we're going to use the negative 1 as the now. And after substituting, we end up getting 2 plus 3, which is 5. Answer choice 3. There are a lot of words in question number 21, but the most important words are average speed. So we know that we are finding the average rate of change between 5 and 10. So you got it, make a table. So here's my table of values, 5 and 10 seconds, and the y values that I got out are 20 and 80. I did this by substituting in 5 into my equation up here, or you could graph this. Remember to use x, and look at the table at the values of 5 and 10. Next, we need to find out how the x changed and how the y changed. So since to get from 2 to 80 we added 60, and 5 to 10 we added 5, my rate of change, my average rate of change between those 2 points would be 60 divided by 5, which is 12. Remember that you can use your calculator to help you with question 22, so you can graph it and look at its roots. Make sure you use x instead of p. But right away, I'm noticing that this is the difference of two perfect squares. So we're going to create a skeleton template, a double skeleton template, because we don't have a GCF. Since p squared times p squared is p to the 4th, and a positive 9 and a negative 9 multiply to negative 81 but add to nothing, this is what I would get in my first step. Then I notice that I only have one difference of two squares. So the first p squared plus 9, that can't be factored anymore. If you graphed that, you'd see there's no roots. No GCF over here, so now we'll do our double skeleton yet again. P times p is p squared. Positive 3 times negative 3 is negative 9, and they add to that nothing because there's not a middle term there. Therefore, giving us the correct answer of 3, since none of those factors can be factored again. Question number 23 is pretty tricky, but we can at least narrow it down to 2 answer choices, and we'll talk why we have to pick answer choice 4 and not answer choice 2. So first of all, we notice that it is a flat rate of 46 cents. So immediately I'm going to get rid of 1 and 2 because it doesn't show that constant of 46 cents. But it does say that it's 20 cents per ounce. The trick here, or the catch here, is that they told us the letter weighs z ounces, not z ounces greater than 1 ounce. So we have to take into consideration the 1 ounce that has already been paid for, so we subtract it away. That's why we have to pick answer choice 4 and not answer choice 2. In question 24, they told us the factors, which I've shown down here, and we need to come up with the graph, or a possibility of the graph. So immediately, I know that there are 1, 2, 3 factors, which means that there are 3 different roots, because all the factors are different. Therefore, graph 2 is out, and so our answer choices 4 and 2. Now, if I look at each one of my factors, I can pull the roots from them. So the factor of x minus 2, I'd have a root at x is equal to 2. Here I'd have a root at x is equal to negative 5. Remember, the signs are always opposite because you would set them equal to 0. And here x is equal to 0. So the only graph that has all 3 of these roots is graph 1, because if you look at graph 3, they're actually the opposite. So graph 3 is out and 1 is in, therefore answer choice 1 is correct.